How can a country where only 2% of the population works in agriculture manage a farming system that covers more than half of its territory? In this video, Agriculture Insight unpacks that paradox. How Australian farmers harness over 1 billion acres of agricultural land, transforming the most arid inhabited continent on Earth into the leading agricultural powerhouse of the Southern Hemisphere, capable of competing with the United States and Brazil in the global food supply game. All will be revealed right now. This is one of the oldest soils on the planet, shaped over millions of years without volcanic activity or glacial replenishment, leaving Australia's land far poorer in nutrients than the fertile black soils of Europe or North America. Not only that, even water does not favor farmers here. Although surrounded by oceans, fresh water is exceedingly scarce. So, how did Australian farmers overcome these challenges to elevate the nation's agriculture into one of the world's leading agricultural export powers? The answer will be revealed right after this. With more than 24,000 farms spread across the southeast and southwest, Australia does not merely raise sheep, it operates a vast natural fiber empire. Unlike the sun-scorched north, these temperate and dry regions provide the essential conditions needed to protect precious merino wool from moisture and mold. On extensive grazing farms, each sheep functions like a resilient fiber factory. At around 6 to 8 months of age, sheep undergo their first shearing, a milestone marking maturity. From then on, the fleece is harvested once a year, using specialized electric clippers. With skilled technique, an experienced shearer can handle more than 200 sheep per day, removing up to 5 kilograms of premium wool from each animal without harming the skin. If a minor cut occurs, a special antiseptic powder is immediately applied to stop bleeding and protect the animal on the spot, ensuring the process remains humane and safe. The wool is then baled and becomes a strategic raw material for high-end textile mills in Italy and Japan. After washing and carding, it is transformed into ultrafine fabrics that are breathable and capable of naturally regulating temperature according to the wearer's body heat. While synthetic fibers can take decades to decompose, merino wool can break down into the soil and become fertilizer in just 12 months. This regenerative property makes Australian wool a top choice for sustainability commitments. Partnerships with brands like Smart Wool and Allbirds are not only about quality, but also a statement of Australia's position as the country that holds up to 80% of global fine wool production. Leaving behind the livestock empires, we move on to the million-dollar fields, a sector that occupies less than 5% of the land, yet generates more than half of Australia's agricultural revenue, officially overtaking livestock to become the country's largest money-making engine. From February to April each year, as temperatures in the Murray-Darling Basin begin to ease, almond hulls naturally split open, signaling perfect physiological maturity. To win the gamble against weather, where a sudden summer rain can trigger mold or prolonged heat can crack the kernels, the entire process has been fully mechanized to eliminate every element of chance. It all begins with self-propelled shakers. A single hydraulic clamp and a few seconds of high-frequency vibration are enough to detach ripe almonds from the trees, dropping them onto leveled ground to dry naturally. The region's harsh sun and wind reduce kernel moisture from around 25% to below the 6% standard within roughly 10 days. Once optimal dryness is reached, sweepers and harvesters move along the rows, using powerful airflows to lift the almonds while keeping their protective shells intact. The smart part lies in the system's integrated centrifugal filters, which remove twigs, debris, and stones directly in the field, ensuring maximum purity for an annual output exceeding 100,000 tons. Strict control of this golden window allows almonds to be processed and packaged within just 24 hours of harvest, a key factor in preserving natural crunchiness and minimizing the risk of moisture or discoloration. Few realize that Australia harvests almonds counter-season to the Northern Hemisphere. When stockpiles in California, the world's largest almond hub, begin to age after months in storage, the market is instead supplied with freshly harvested Australian almonds. This seasonal advantage allows Australian almonds to compete on freshness and natural flavor, rather than scale alone. When it comes to wine grapes, many people immediately think of France. Yet in Australia, this fruit powers an industrial engine just as formidable, with more than 2,000 wineries distributing over 1 billion liters of wine each year. Australia has firmly held a top 5 global position for decades. Most Australian vineyards are located in hot, dry climates with high solar radiation, conditions that challenge many European grape varieties, but instead favor the two pillars of Australian wine. Most notable is Shiraz, a thick-skinned, heat-tolerant grape that accumulates high levels of phenolic compounds, producing bold and full-bodied red wines. Alongside it stands Chardonnay, the backbone of Australian white wine, valued for its high adaptability, solid structure, and resistance to being overpowered by oak. During harvest season, New Holland broad machines rated at 175 horsepower become the workhorses of large vineyards. Their high-clearance chassis allows stable movement between vine rows, while high-frequency shaking units precisely detach ripe grapes without damaging the skins. Immediately behind, variable pressure fans continuously blow away leaves, stems, and debris in a single pass. Each machine can process more than 20 tons of grapes per hour, equivalent to the output of roughly 40 manual workers operating continuously. To manage temperature challenges in hot regions such as Barossa or Riverland, night harvesting is mandatory. The cooler pre-dawn temperatures help lock in grape condition, prevent oxidation and premature fermentation, and preserve natural acidity. This is a critical technical factor in maintaining freshness in wines from hot climates, something traditional methods struggle to achieve at scale. For old vine vineyards, hand harvesting is selectively maintained. Skilled workers carefully cut each cluster to preserve the natural bloom and aromatic depth required for the highest tier wines. This strategy creates a clear economic distinction. While French wines often rely on rarity and vintage variation to command prices of thousands of dollars, Australia leverages modern production systems to deliver consistent quality in the USD 20 to 50 range, a practical price point for wines that are bold, varietally expressive, and clearly reflective of their regional character. Leaving behind the lush vineyard valleys, we head north to Australia, where the cotton industry operates like a ruthless factory, exporting more than 600,000 tons of finished product and generating USD 2 billion in revenue each year. Here, the role of human labor during harvest season has been completely replaced by massive machines. These are not merely harvesters, but mobile operating complexes. Rotating spindle systems, fitted with ultrafine steel barbs, penetrate each cotton plant to pluck the fluffy white fibers with absolute precision, removing impurities directly from the branches. As soon as the storage chamber is full, an integrated hydraulic compression system automatically forms the cotton into round modules weighing over 2 tons, wrapped in specialized plastic film to preserve moisture balance and fiber purity against all weather conditions. From this point, these giant cotton modules must be transported to processing facilities within a critical 24-hour window to prevent deterioration caused by residual moisture, ensuring the fibers remain in optimal condition before entering the ginning stage. At the mill, high-speed saw systems and powerful airflows carry out seed separation, fiber opening, and fine dust filtration. This process transforms rough fiber masses into raw material with uniform length and exceptional whiteness, up to 50% more durable than synthetic fibers and 20% more absorbent, making it the gold standard for luxury fashion brands. In Australia's vast grain belt, where annual rainfall can sometimes fall below 300 millimeters, wheat stands as a marvel of both biology and engineering. The varieties grown here are specially bred to become super warriors, with exceptionally deep root systems that extract every last drop of water from the parched soil in order to survive and mature. When harvest season arrives, stretching from August through January of the following year, the harsh heat is transformed into a strategic advantage. Wheat dries naturally right in the field, reaching an ideal moisture level of below 12% without the need for costly industrial drying. This is precisely the privilege that allows Australian wheat to maintain some of the most competitive pricing on the global market. Across the endless golden fields, fleets of combine harvesters line up like a modern mechanical army. Each machine functions as a real-time analytical center, harvesting while simultaneously using sensors to measure protein content and instantly classify grain quality in real time. The key lies in seamless, uninterrupted coordination. Thanks to high-precision GPS positioning systems, harvesters automatically navigate the fields and unload grain into tanker trucks while still in motion, maintaining 24/7 operations in a race against time before incoming storms can degrade grain quality. However, the contest with nature is not always favorable. In recent years, scattered late-season rainfall across eastern and southern Australia has downgraded part of the harvest, forcing a shift from premium milling wheat to livestock feed. Even so, through early harvest strategies and rapid mechanization, overall output has remained above the 10-year average. In the end, this is not merely a story of export revenues, but a testament to an agricultural system capable of turning harsh conditions into sustainable profit. To supplement its water supply, Israel chose an exceptionally smart approach, desalinating Mediterranean seawater. With a long coastline, stable salinity, and minimal exposure to natural disasters, these waters allow mega-scale plants to operate 24/7, regardless of weather conditions. The key lies in reverse osmosis technology. Seawater is forced through ultrafine, semi-permeable membranes under extremely high pressure, allowing pure water molecules to pass through, while salts and impurities are retained, producing water that meets domestic consumption standards. What truly sets this technology apart, however, is not filtration alone, but energy recovery systems. By harnessing residual pressure from the concentrated brine stream to compress incoming seawater, Israel has reduced electricity consumption by up to 40%. As a result, production costs have fallen to a record low, less than $1 per cubic meter, among the lowest in the world. The outcome is striking. Around 80% of Israel's domestic water supply now comes from the sea, virtually eliminating dependence on natural rainfall. However, desalinated water is extremely expensive to produce and transport, so it is prioritized primarily for domestic use. To sustain large-scale agriculture in the desert without draining the national budget, Israel activated an often overlooked resource: urban wastewater. This solution has propelled Israel to the global lead, with up to 90% of its wastewater reused, 3 times the rate of the United States. At megascale treatment plants, wastewater containing organic pollutants and microorganisms is fed into massive aeration tanks. Here, bacteria act as natural decomposers, consuming and breaking down harmful organic compounds, transforming dark, contaminated flows into basic clean water. Next, pressure filtration systems and centrifuges completely remove solid impurities and sludge from the stream. This closed-loop process ensures that not even the smallest debris escapes, preparing the water for the most critical purification stage beneath the ground. The water is then directed to desert reservoirs for soil aquifer treatment, the most crucial step in the water regeneration chain. It slowly percolates through sand layers, reaching depths of up to 100 meters, using the earth itself as a vast biological filter to fully eliminate bacteria and remaining contaminants. From this point, the regenerated water reaches a purity comparable to drinking water, sustaining over 60% of agricultural land in the Negev desert at a cost only 1/3 that of desalinated water. But water alone is not enough. For centuries, drawing water from wells was one of the most backbreaking tasks in arid regions. Jewish settlers in the Negev and the Jordan Valley were forced to haul bucket after bucket up from the ground, then carry heavy canisters on their shoulders to irrigate their fields. Water was scarce, labor was intense, and most of that effort simply evaporated under the desert sun. Today, more than 90% of Israel's cultivated land has been transformed by drip irrigation technology. While Israel did not invent the principle, it was the first country to commercialize it and turn it into a fully integrated, large-scale system, operating reliably across open fields and sealed greenhouses alike. After passing through filtration units, water is pushed into main pipelines and then distributed into smaller lateral lines running parallel along planting rows. Along each line, drip emitters are placed 40 to 60 centimeters apart, precisely where root activity is strongest. So water does not spread wastefully, but is delivered exactly where plants actually need it. Unlike flood irrigation or overhead spraying, drip irrigation fundamentally solves the long-standing inefficiencies of manual watering. Pressure-regulating valves and automated controllers allow farmers to precisely control flow rates and timing, delivering water steadily into the root zone. As a result, leaves remain dry, soil surfaces are left undisturbed, and most importantly, water loss through evaporation is nearly eliminated. In mushroom farms, where thousands of delicate caps have no roots to draw water, drip irrigation becomes a tool for controlling life itself. Water is supplied in ultra-small doses, slowly absorbed, just enough to maintain optimal humidity for mycelium growth. Here, drip irrigation is no longer about watering, it is precision management of the microbial environment. And now, welcome to the Jordan Valley, the lowest place on Earth, and also the most unforgiving heat basin in Israel. Here, where temperatures of 45 degrees Celsius can scorch nearly all life, and salt-crusted soil gleams white like snow, conditions long considered a death sentence for crops become an absolute advantage for date palms. The medjool date, often called the black gold of the desert, is the star of this landscape. Extreme heat triggers intense sugar accumulation, while soil salinity naturally eliminates pests, allowing the dates to grow completely clean, without chemical intervention. However, producing export-grade dates with near-perfect uniformity requires deep technical intervention. Each mature date palm needs around 700 liters of water per day at the peak of summer. This massive volume is drawn from the Jordan River and delivered through intelligent drip irrigation systems, directing each drop precisely to the root zone, sustaining life without increasing soil moisture, a critical factor in preventing fungal growth on the fruit. From August to October, as harvest season begins, date clusters do not ripen uniformly and are therefore monitored closely day by day, cut only at the exact moment when sugar content reaches its peak. Harvesting is assisted by specialized hydraulic lifting platforms, allowing workers to reach individual fruit bunches at heights of up to 20 meters. Each cluster is cut by hand, then slowly lowered using pulley systems to prevent impact or surface damage. The moment the dates leave the canopy, the clock starts ticking. Within a 6-hour golden window, they must enter processing facilities for controlled cooling and drying. This critical step locks in the fruit's flesh structure and its concentrated sweetness. Few realize that while medjool dates can be grown in many regions, only in Israel do they reach such exceptional size, richness, and a soft, toffee-like texture that the world relentlessly pursues. Once a luxury tribute offered to Roman emperors, medjool dates today generate up to $350 million USD annually. With an average yield of 120 kilograms per tree, double the productivity of California, America's date capital, this stands as the clearest proof of Israel's mastery over precise water control, ripening timing, and sugar accumulation rhythms, something even temperate climates have yet to achieve. A naturally grown cherry tomato plant yields only 20 to 40 fruits. But in Israel, where nearly the entire national tomato export supply is produced, a single plant can deliver up to 400 tomatoes. The secret lies in a suspended growing system using sterile hydroponic substrates, which completely isolates the root zone from nutrient-poor desert soil and cuts off the risk of infection by tomato brown rugose fruit virus, TBRV, the most dangerous threat to tomatoes in hot, humid greenhouse environments. This record-breaking productivity is sustained through precision drip irrigation, where every drop of water and nutrients is delivered directly to the roots, maximizing sugar accumulation and achieving high brick sweetness without waterlogging or losses from evaporation. And to produce clusters with crystal-like sheen and consistent flavor, Israel relies on a factor no machine can replace: bumblebee pollination using polyam hives. In sealed greenhouses, where honeybees often lose orientation, bumblebees are the only effective vibration pollinators, increasing fruit set rates by 20% and creating uniformly plump, glossy, deep red tomato clusters. After roughly 100 days of intensive nutrient accumulation, when a uniform red hue spreads across the fruit and the skin reaches a crystal-like gloss, the king of sweetness is ready for its peak harvest. Harvesting is carried out entirely by hand. One hand makes a clean cut with pruning shears, while the other gently supports the fruit to protect its delicate skin from even the slightest abrasion. This level of precision is mandatory to meet the requirements of export markets. Over 80% of production is shipped to Europe and Russia, regions known for their exceptionally strict standards on appearance and biosecurity. With yields reaching 300 tons per hectare, Israel's greenhouse model has set a new global benchmark for productivity. Despite high infrastructure costs, its superior quality control and a record 40% reduction in water consumption have created a competitive advantage unique to Israel on the world's agricultural map. Moving beyond greenhouses, Israel is bringing artificial intelligence into open fields with autonomous apple harvesting robots. As global labor shortages intensify, these robotic fleets are gradually replacing human workers during harvest season. Equipped with computer vision, the robots scan entire canopies, assess ripeness and size, and detect even the smallest blemishes on apples while they are still on the tree. Once a fruit meets the standard, it is picked using vacuum suction grippers or soft clamps, ensuring zero surface damage. The true breakthrough lies in 24/7 operation. These robots can work through the night under specialized LED lighting, enabling rapid harvests ahead of unpredictable weather. The result, up to a 50% reduction in labor costs, while simultaneously upgrading fruit quality. This is how Israel transforms traditional apple orchards into intelligent production lines, as precise and efficient as a high-tech manufacturing plant. Across Asia, behind the nearly 5 million tons of white-leg shrimp exported each year, lies a decades-old paradox. The pond bottom, where shrimp spend most of their lives feeding and breathing, is actually the most oxygen-deprived layer of the entire system. As traditional paddle wheels only stir the surface without addressing this fundamental bottleneck, the shrimp industry has been forced to confront the root of the problem. Oxygen must be delivered exactly where the shrimp live, not left floating in the upper water column. This is why pure oxygen technology emerged as a true turning point. Instead of relying on slow natural diffusion, the system extracts pure oxygen from the air, compresses it into high-pressure microbubbles, and drives it straight into the pond bottom, a zone that almost no previous technology could reach. As a result, shrimp don't just breathe better, they escape the toxic bottom environment entirely. Their metabolism improves, immunity strengthens, and survival rates can increase by around 20%. A number powerful enough to redefine the profitability of an entire farm. Unlike traditional square cages, circular cages use an arched load distribution structure. In this closed-loop design, forces from waves, wind, or currents are evenly spread across the entire frame, instead of concentrating at a few stress points as in square cages. As a result, the cage does not twist, shift off-center, or develop fatigue points that lead to long-term structural failure. When a large wave hits one side, the force is carried around the circular frame, allowing the cage to move smoothly with the wave, rather than resisting it. This absorb-disperse balance mechanism enables the structure to maintain its shape, even in seas with 3 to 4 meter waves. Waters with strong currents and high dissolved oxygen, ideal for species like salmon, yellowtail, and tuna to grow naturally, build muscle mass, and improve flesh quality. Most veteran marine engineers consider offshore circular cages the true starting point of industrial open ocean aquaculture. Since their introduction, marine farming has finally been able to move beyond shallow coastal zones and into deeper, cleaner, and far more stable waters, suitable for large-scale production. Not every sustainable aquaculture model requires closed-loop systems or massive steel structures in the open ocean. In Coffin Bay, South Australia, where the tide rises and falls twice a day, and the water is rich in plankton, farmers choose to work with the environment rather than replace it. Each year, rows of oyster baskets are positioned exactly within the most active flow layers, allowing oysters to grow according to their natural physiology. These baskets are made from ultra-durable polymers and designed as rotating cylinders suspended on an adjustable lawn-line system. As currents pass through, each basket rotates gently, smoothing the shell surface, removing fouling organisms, and channeling oxygen down to the bottom, helping oysters build thicker shells, deeper meat, and a perfectly shaped cup. Each basket is less than 30 centimeters wide, yet its rigid frame can hold around 200 juvenile oysters. Thanks to the optimal water conditions and a farming method built entirely around natural current dynamics, Coffin Bay oysters not only reach market size, but also develop thick shells, deep cups, and uniform shape, qualities rarely achieved in conventional oyster farming. This distinction is what allows Coffin Bay oysters to be welcomed in demanding markets such as Japan and Singapore, where consumers are willing to pay significantly higher prices compared to standard farmed oysters. Compared to offshore cage farming, where fish and shellfish grow in HDPE structures engineered to withstand 3 to 4 meter waves, high oxygen levels, and constant currents. The intertidal rack and stick method represents a minimalist but intelligent approach. Instead of relying on steel frames, dozens of hectares of tidal flats use more than 50,000 stakes, working entirely with natural water cycles. Cage farming delivers high output and industrial-scale production, while intertidal farms produce oysters with thicker shells, firmer meat, and a distinct flavor shaped by the natural dry-wet rhythm that no artificial system can fully replicate. To catch hake, modern trawlers rely on a fishing system that is almost fully mechanized. The entire net, stretching 300–500 meters, is packed into a massive hydraulic net drum weighing tens of tons. When sonar pinpoints a moving school, the captain triggers the release. 2 trawl doors swing open, holding the mouth of the net steady at the exact depth where hake are swimming. Throughout the tow, sensors mounted on the doors constantly transmit data on tension and depth, allowing precise adjustments within seconds. Once the code end reaches capacity, typically 20 to 40 tons of hake in a single haul, the drum reverses, retrieving the net along a programmed path that minimizes twisting and stress. As the code end breaks the surface, a single latch is released, and the entire mass of hake spills onto the deck, completing a harvesting cycle driven almost entirely by heavy machinery and automation. But their ambitions didn't stop at the 10-kilometer mark. China's leading engineers pushed even further, developing an industrial-scale fish farming system capable of operating stably in open waters as far as 60 kilometers offshore. With a diameter of 180 meters and a semi-submersible steel frame weighing more than 7,000 tons, the entire structure is assembled on land before being towed to its ideal offshore location. A zone with strong currents, clean water, and minimal human influence. These conditions allow the fish to develop firmer muscles, lower fat content, and overall better health compared to those raised in nearshore farms. Seaweed farming may still be unfamiliar to much of Europe, but a movement to build offshore seaweed farms is emerging as a natural extension of the blue economy. In Norway, commercial-scale farms now operate on 15 to 20 hectares, with long-line systems stretching for tens of kilometers, producing hundreds of tons of seaweed each season. These ocean fields rely entirely on natural currents, tides, and nutrients drifting from nearby fish farms, allowing seaweed to grow without fertilizers or chemicals, a truly ocean-based form of agriculture. Seeded in autumn, the seaweed matures quickly, and after just 6 to 8 months, farmers can harvest it using mechanized equipment, where lifting, hauling, and collecting have become almost fully automated. Although European offshore farms have yet to reach the multi-thousand-ton scale of Asia, they are demonstrating a different kind of value: carbon absorption. According to recent trials, each hectare of seaweed can capture 10 to 30 tons of CO2 per year, depending on species and current strength, a number significant enough to position seaweed as a key piece in Europe's long-term decarbonization strategy. Modern parsley root harvesters have completely transformed the way farmers collect this delicate root crop, turning a once meticulous job that required dozens of manual workers into a fast, clean, and highly precise mechanized process. Commonly used in Germany, Poland, and the Netherlands, these machines can handle up to 3 to 4 tons per hour, pulling roots straight from the soil, cleaning off dirt, and gathering them neatly into storage bins right on the field. At the front, a V-shaped shear opens the bed and lifts the soil at the exact depth, preventing breakage of the fragile roots hidden underground. Immediately behind it, a soft twin-clamp system grips the stems and pulls the roots upward in a straight motion, minimizing scratches and bruising. A series of rubber conveyors and vibrating soil separators gently carry the roots to the collection deck, removing up to 80% of soil without damaging their skin. On high-end models, such as those from ASA Lift or Simon, rotary brushes combined with air jets further eliminate debris during operation. Thanks to advanced technology, a single machine can replace more than 20 manual workers, cutting harvest time by up to 90% while keeping the roots uniform, intact, and ready for washing and packing. In North Rhine-Westphalia, Germany, home to Europe's largest parsley root farms, these harvesters have become symbols of productivity and precision in modern agriculture. This agile little steel monkey is an automatic tree-climbing pruner, a compact machine that is reshaping the future of fully mechanized forests. Once clamped onto the trunk, it ascends dozens of meters vertically, using a hydraulic gripping system and high-friction drive wheels, trimming branches on all sides as it climbs with a seamless 360-degree cutting rotation. Along its body, ultra-high-speed steel blades sweep through the limbs in seconds, leaving the trunk straight, smooth, and free from bark damage, a level of precision that manual labor can rarely achieve. When it reaches the top, the machine automatically reverses direction and slides back down, completing a full pruning cycle in just 3 to 5 minutes per tree, making it up to 15 times faster than human workers. With its high accuracy and ability to operate on steep terrain, dense forests, and mountainous regions, this robot has become the steel arm of Northern Europe's forestry industry, reducing risk, boosting productivity, and standardizing log quality for premium timber markets. Each thundering pass feels as if it shakes the earth itself. The blade plow, a deep tillage giant built for rock-hard, root-bound, sun-baked soil, was born to conquer the toughest ground on the planet. Hidden beneath clouds of dust is its massive V-shaped plow blade, capable of slicing down to 70 centimeters, ripping through compacted layers and freeing soil that has been locked and suffocated for years. Pulled by hundreds of tons Caterpillar D12 tractors, the entire system moves like a single mechanical organism. Hydraulic cylinders drive the blade deep into the ground, and colossal steel press wheels follow behind to smooth and level the surface, leaving a soft, uniform strip of soil ready for farming or ecological restoration. What sets the blade plow apart is not just its brute force, but its ability to liberate the soil without destroying it, preserving moisture, maintaining natural structure, and minimizing erosion. Instead of tearing the land apart, it awakens it, opening pathways for air, roots, and life to return. On once dead ground, this machine lays the foundation for new growth, a fresh beginning for landscapes long forgotten. However, bigger isn't always better. On vegetable farms, terrace fields, and small rugged plots, mini tillers, compact, hand-guided machines, become the lightweight fighters that punch far above their class. Powered by fuel-efficient gasoline engines, these machines drive their force into high-speed rotary blades, completing an entire soil prep cycle in a single pass, tilling, cutting, loosening, mixing fertilizer, and forming beds all at once. Small doesn't mean weak. A mini tiller can break 10 to 15 centimeters deep, turning hardened ground into a soft, fluffy seedbed ideal for planting. In November, when the lemon groves of Murcia in southeastern Spain glow gold beneath the Mediterranean sun, the harvest season reaches its peak. In an age of full mechanization, Spain has chosen the human hand over machines, with more than 70% of its lemons still picked manually, preserving the sun-soaked aroma, coastal winds, and essential oils within every golden fruit. With a pair of specialized clippers, workers snip each lemon gently at the stem, careful not to damage the glossy, oil-rich skin, the key to premium export quality. When the side bags fill up, the lemons are poured into large crates lined along the rows, each basket of gold stacking higher like waves of light, before being loaded onto trucks and sent straight to sorting facilities. Despite its devotion to tradition, Spain maintains a steady yield of over 1.2 million tons a year, securing its place as the lemon capital of Europe. Continuing our journey to the United States, deep inside Hawaii's vast macadamia orchards, spanning hundreds of hectares. The show opens with the calculated dance of the tree shaker. Its hydraulic arm clamps tightly onto the trunk and delivers perfectly tuned vibrations, strong enough to send thousands of ripe macadamias raining down, yet gentle enough to protect branches and foliage. Moments later, the sweeper vacuum harvesters roll in, modern hybrid machines that can sweep and collect in a single pass. Soft rotating brushes funnel the nuts into clean rows, while a high-pressure vacuum system swallows them into a filtering chamber, separating leaves and soil before transferring pristine macadamias into the rear bin. Each machine can process over 2 tons per hour, multiplying productivity by tens of times and turning an entire orchard into a synchronized, mobile harvest line. With an annual output of over 18,000 tons, Hawaii stands not only as the macadamia capital of the United States, but also as a symbol of a global premium nut industry worth over $1 billion USD, where every macadamia is harvested with cutting-edge technology and the enduring pride of island farmers. On the steep hillsides of Switzerland and Austria, conventional tractors are nearly powerless. The Brielmeier liquid fertilizer machine rises to the challenge, delivering nutrients to places agricultural technology once considered unreachable. Engineered specifically for mountainous terrain, compact, powerful, and remarkably agile, the machine uses a massive steel-spiked front roller to grip the ground, maintaining perfect balance even on slopes exceeding 40 degrees. At the rear, a high-pressure rotating sprayer projects liquid fertilizer up to 30 meters, fed directly through pipelines connected to reservoirs down in the valley, allowing uninterrupted operation without constant refilling. Thanks to an intelligent electronic control system, operators can stand safely at a distance, adjusting spray angle, pressure, and flow rate from a simple control panel. Another equally fascinating piece of farm machinery is the mini tunnel greenhouse machine, created for small and medium-sized vegetable farms where unpredictable weather can decide the fate of an entire season. Instead of spending days building low tunnels by hand, farmers now only need a single machine to lay the film, bend the hoops, and form continuous mini tunnels within minutes. At the front, a coil of slim steel tubing is fed into a precise hydraulic former, shaping it into perfectly uniform arches one after another. Immediately behind, a roll of transparent plastic film is pulled forward and stretched over the frame, kept tight by a heated roller system, then fastened securely to the soil with automatic clamps, creating a seamless row of compact tunnels that block wind and retain optimal humidity for young crops. In just 1 hour, the machine can build hundreds of meters of mini greenhouses, shielding seedlings, strawberries or tomatoes from frost, heavy rain, and sudden temperature drops. Compact, easy to operate, and impressively efficient, the mini tunnel greenhouse machine is more than just a cover-laying tool. It is a mobile climate shield, giving farmers the power to control their environment and ushering in a new era of flexible cultivation. The Etgar harvester, an innovation from Israel, is one of the most advanced chili pepper harvesters in the world. Engineered to swallow dozens of crop rows in minutes with near-perfect precision, compact yet brilliantly designed, it uses 2 counter-rotating helical rollers that act like a pair of steel hands, guiding each plant into the separation chamber, gently detaching ripe peppers from their stems and lifting them onto a conveyor belt. A powerful airflow system removes leaves and branches, leaving only clean, intact peppers to glide toward the end of the line. Artichokes, the elegant, slow-tempered treasure of Castroville, California, demand a harvest rhythm that values patience over speed. Unlike many modern crops ruled by machines, artichokes insist on the gentle precision of human hands. Timing is everything. The perfect bud is one whose outer petals remain tightly closed, the stem still vibrant green, and the head measures 7 to 10 centimeters. Just a short delay, and the bloom will open, losing its tenderness, aroma, and market worth. Harvesters move carefully through the fields at sunrise, using a sharp curved knife to cut the stem about 5 centimeters below the bud. Each artichoke is then placed softly into a basket on the worker's back, because even the smallest scratch can blemish the leaves within hours. What looks simple is, in reality, a craft of touch, timing, and intuition passed down through generations. In a world racing toward automation, the artichoke stands as a quiet rebellion, a reminder that not all beauty can be accelerated. It remains the green muse of Mediterranean cuisine, celebrated for its purity and grace. Between the earth, the grower, and time itself, the artichoke preserves a harmony that no machine has yet been able to imitate.